Hello everyone. Today we are going to discuss about some basic definitions of the electrical circuits. Okay. Now the definitions like what is node and what is branch and what is loop and what is unilateral element, what is bilateral element and what is linear element and what is non-linear element. Some basic definitions we will discuss today. Okay. So in that the first definition is linear circuit. So first of all, what is linear circuit? A circuit or a network whose parameters, that is R, L, C, resistor, inductor, capacitors of resistances, inductances and capacitance are always constant irrespective of the change in the time, voltage and temperature, etc. is known as a linear circuit. Okay, so if you see the resistor, inductor, capacitor values, the values will not change even if you change in the circuit. If you change the temperature, or if you want to change the time, or if you want to change the voltage, or if you change any parameter, if you want to change anything, you can change, but there is no change in the parameter. The characteristics will not change of the resistor, inductor, capacitor is called as a linear elements. Okay, the parameters of the all these elements, resistor, inductor, capacitor, are constant, are same if you change time, temperature and the voltage. That's why these are all called as a linear elements. These linear circuits are applicable for the Ohm's law. The Ohm's law can be applied to the linear circuit. Okay, got it. So this is about the linear circuit. If you see the examples of the linear circuit, so the resistor is also one. Resistor is an example of the linear circuit. Okay, now if we take the symbol, so this is the symbol of the resistor. Okay, now the resistor is indicated by the letter R. Okay, this is about the resistor. Now if we take the one more linear circuit, that is inductor. Inductor is indicated by the letter L. Okay, this is the one of the linear circuit, a linear element it is. And now if we take the one more example of the linear element, that is a capacitor is a linear element. One linear circuit is a combination of all the resistors, or it may be the combination of resistor and inductor, or it may be the combination of resistor, inductor and capacitors. Okay, the circuit is which is having the resistor, inductor and capacitor is called as a linear circuit because these elements obeys the Ohm's law. Okay, the values will not change if we change the voltage, current or temperature. If you change anything, the properties of the elements are the same, that is constant. Okay, now if we take the characteristics of these linear elements, so if we take the this is the I'm taking on y-axis, I am taking the current, and x-axis I am taking the voltage. Okay, so here on x-axis we are increasing the voltage continuously, and here current also we are increasing the continuously. Okay, if there is a if you change the voltage and there is a change in the current, okay, so linearly the both are increasing. Okay, if you increase the voltage, there is a increasing the current also. That's why we are getting the linear characteristics. Okay, from this we can say that this resistor, inductor, capacitor obeys the Ohm's law. Okay, that's why Ohm's law is having the linear characteristics. So from this we can say that these elements, resistor, inductor, capacitor, are the elements which are called as a linear elements. Okay, this is about the linear circuit. Now if we take the non-linear circuit, if you see the definition of the non-linear circuit, a circuit whose parameters change their values. If we change the value, if we change the time, temperature and the voltages, the parameters changes. Okay, that's why these elements are called as a non-linear element. That circuit is called as a non-linear circuit. Okay, this non-linear circuit does not obey the Ohm's law. If you see the non-linear elements, okay, these diodes and transistor are called as a non-linear elements because if we for this diodes, if we supply the voltage, and if you change, if you increase the voltage, and if you increase the temperature, or if you increase the time, if you change the time, then the parameters of the diodes and the transistor will change. That's why this diodes and the transistor are called as a non-linear elements. Okay, if we see the characteristics of the non-linear elements, so for example, it is assumed that it is I. On y-axis, I am assuming that I. On x-axis, I am assuming that it is a V. Okay, we are increasing the voltage on the x-axis, and we are increasing there is a change in the current on the y-axis. Okay, so if we take the diode characteristics, so there is, if you increase the voltage, okay, continuously. So here if you see if we take the silicon diode, there is a cut-in voltage is 0.7 volts. Okay, this voltage is called as a cut-in voltage. So up to 0.7 volts, there is no conduction here. Suppose if we take the example of the nonlinear characteristics here, so this is the cut-in voltage. So initially you are taking the 0 volts. If you are giving the 0 volts, if you give the 0 volts, there is no change in the current. Current is approximately equal to 0. Okay, if we increase the voltage from 0 to 0.1 volts, then also the current is here, the current is equal to 0 here. Okay, the current we will get 0. So if you increase the voltage again to 0.2 volts, okay, there is no change in the current here. Okay, now if you increase the voltage from 0.2 to 0.3 volts, the current is also 0. Current is 0. Okay, and here if you increase the voltage from 0.3 to 0.4, there is no change in the current. Current is 0. And if you increase the voltage from 0.4 to 0.5, and there is no change in the current here. Okay, here current is 0. If you increase the voltage from 0.5 to 0.6, here current is 0. Now if you take the current is voltage is equal to 0.7 volts, the supply voltage, it is called as a cut-in voltage of the silicon diode. Here there is a increase in the current here. It starts increases. So here, see here, observe here, up to 0.7 volts, the current is up. So up to here there is it is totally it is 0. So from here to here there is a small change in the current, but it is increasing drastically after 0.7 only. This is the cut-in voltage of the diode. So here if we are increasing the voltage, but there is no change in the current here. Current is 0 total up to 0. But after 0.7 only the current is increasing. Okay, as we are increasing the voltage, but there is no change in the current. These characteristics are called as a non-linear characteristics. If you increase the voltage, there is no change in the current. Current is not increasing. These type of characteristics are called as a non-linear characteristics. Up to 0.7 volts, the current is 0. After 0.7 volts only, it starts conducting. Okay, these are this is the diode forward bias characteristics. Okay. This voltage and the current are not linear. These are the non-linear characteristic. It is having the non-linear characteristic. That's why this diode and the transistor are both are having the non-linear characteristic. That's why we are taking the examples of the non-linear elements are the diode and the transistors. Okay, so this is about the non-linear element. Now, if we take the one more element, that is called as a bilateral circuit. Okay. So bilateral circuit are nothing but a circuit whose characteristics or behavior is same irrespective of the direction of the current through the various elements of it is called as the bilateral elements. So here if we change the direction, there is no change in the characteristics of the element. The characteristics or the behavior are same. If you change the direction of the current, this circuit is called as a bilateral circuit. If you take the examples of the bilateral circuit are this resistor and the inductor and the capacitor are called as the bilateral elements. Okay, so if you take the resistor, it is denoted by the letter L, and if you take the inductor, it is denoted by the letter L. It is R and it is L, and the capacitor is denoted by C. Okay, in the bilateral elements, so if you take one example here, so I am taking the one resistor here. Okay, one resistor. Okay, assume that this is one circuit. This is one circuit. This resistor is having 2 ohms of the resistance. Okay, and the supply supply is I am giving 10 volt supply. Okay, how much current is flowing? If we apply the Ohm's law here, if we want the current, I is equal to V by R. Okay, what is the V value here? V is 10 volts, and what is the R value? 2 volts. What is the current we are getting? The current we are getting is 5 amperes. Okay, assume that 5 amperes of current is flowing here. Okay, it is a 5 amperes of current is flowing from this negative terminal to the positive terminal. Okay, the current is flowing like this in the clockwise direction. The current is flowing. Now I'll do one thing. I will interchange the battery terminals. Okay, I will interchange the battery terminals. So, okay, assume that it is a negative terminal and it is a positive terminal. Okay, this the resistor value I am not changing here. So it is having the 10 volts. Okay, just I am interchanging, it is a negative and positive. Before it was positive and negative, just I am interchanging the terminals. Now we have to find out the current passing through the circuit here. So now if we take the current passing through the circuit, so actually it is not positive here. Okay, here now I am applying Ohm's law here. Same for the same circuit, if you apply the Ohm's law, is equal to V by R. What is the V value here? 10 divided by what is the R value here? 2. What is the current we are getting here? Also we are getting the current 5 amperes, but the direction is opposite here. Okay, the direction is opposite. Which current? How much current is flowing here? 5 amperes of current is flowing. Okay, is there any change in the current value? There is no change in the current value, but only that the direction is changing. Okay, from this we can say that this resistor, inductor, capacitor are called as the bilateral elements. In this, the behavior of the characteristics or behavior of the element is same if you change the direction of the supply. Okay, if you change the direction, if you change the terminals, only the direction is changing here. The value magnitude is not changing, only the direction is changing. If you interchange the terminals, there is no change in the property or there is no change in the value. That's why these elements are called as a bilateral element. This circuit is called as a bilateral circuit. In the bilateral circuit, if you interchange the terminals, there is no change in the magnitude. There is no change in the value, only the direction is changing. Okay, these resistor, inductor, capacitors are called as the bilateral elements. Okay, this is about the bilateral elements. Now let's see about the unilateral element. So the unilateral element definition is a circuit use operation or the behavior is dependent on the direction of the current through various elements is called as a unilateral element. So in the unilateral elements, if we interchange the terminals, the property will change. The how it is changed, now we will see. The examples of the unilateral elements are the diodes and transistors. Now if we see the diode here, now I am taking the diode. This is the diode symbol. For this diode, I am giving the forward bias. It is the positive terminal of the battery and the negative terminal of the battery. It is a positive terminal and a negative terminal. It is a P type of the diode and it is a N type of the diode. So here, positive terminal of the battery is connected to P and the negative terminal of the battery is connected to N. Now we can say that the diode is in which bias? The diode is in forward bias. In the forward bias, the diode is in on condition. Okay, in forward bias, the diode is in on condition. In forward bias, diode is in on. That's why the current starts flowing. The current starts increases. Now, if we take the now we will interchange the terminals. If we interchange the terminals, what will happen? We'll see. Okay, now I am interchanging the battery terminals. Before it is plus and minus. Now it is minus to plus here. Battery, it is a minus terminal of the battery. It is a plus terminal of the battery. Okay, it is a positive P type and it is a N type. Here, negative terminal of the battery is connected to P and the positive terminal of the battery is connected to N. We connected reverse here. Now, from this we can say that the diode is in reverse bias. When the diode is in reverse bias, here the diode is in off condition. Okay, here the current is starts increases. Okay, here current is approximately equal to 0 here. Okay, from here the property is almost reversed here. Okay, here if the diode is in forward bias, the some current is flowing, but if you connect in the reverse bias, if you interchange the terminal, the current is equal to 0. It is a total opposite. It is a forward bias and reverse bias, both are approximately opposite here. So that's why from the unilateral definition we can say that a circuit use operation or behavior is dependent on the direction of the current. Okay, here the property of the diode is changing if you interchange the terminals. If you interchange the terminals, now here forward bias. Now if we interchange the terminals, now it will become a reverse bias. So the property of that this element, this device is changing if you interchange the terminal. That's why this circuit is called as a unilateral circuit. The examples of the unilateral circuits are the diodes and the transistors are the unilateral elements. Okay, this is about the unilateral element definition. Now we'll see some more definitions. Now we'll see the node here. Okay, what is node? A node is a point where the two or more branches are connected together is called as a node. Okay, now if we see one example here, we can identify easily how many nodes are there. If we take this example, a node is a point where the two or more branches are connected together. So this is the one branch. Okay, this is the one branch. This is the one branch. These two or more branches are meeting at one point. That's why it is called as a node. Okay, this is called as a node. Okay, now if we take one more example here, if we take one more example, this circuit is consist of, there are two nodes here, one branch, this is one more branch, this is one more branch. Here three branches are meeting at one point. That's why it is called as a node 1. Assume that it is a node 1. Okay, now it is a node 1. Now this is also node because this is a one branch, this is a one branch, this is a one branch. This all the branches are meeting at one point. That's why it is also called as a node, but it is a node 2. Okay, so in the above circuit, how many nodes we are having? The number of nodes we are having in the above circuit is, the number of nodes are 1 here. Okay, so now here if we take this circuit here, this is also called as a node and this is also called as a node. The number of nodes in the above circuits are, the nodes in the above circuit are 2 because the these three branches are meeting at this point and these three branches are meeting at this point. That's why this circuit is consist of 2 nodes and this circuit is consist of 1 node. 2 or more branches are meeting at this node and 2 or more branches are meeting at this point and there 3 more branches are meeting at this node. So this circuit consists of 2 nodes and this circuit consists of 1 node. Okay, this is about the node. Now if you see the branch here, now let's see about the branch. So branch is generally a two-terminal element such as voltage or current source or the resistor, capacitor, inductor. Okay, in between the two terminals there is an element that is called as a branch. Now if we see the branch circuit, so this is the one of the example circuit which is consist of the many branches. Now we will identify how many branches we are having. So here this is a one terminal, it is a one terminal. In between the two terminals there is a element. This element is called as a resistor. It is called as a one branch. Okay, so here it is also having the two terminals. In between the two terminals there is a element. Which element we are having? We are having the voltage. So this is also called as a branch. Okay, in between the two terminals there is a resistor. This is also called as a branch. Okay, in between these two terminals there is a one more resistor R3. It is also called as a branch. Okay, here in between the two terminals there is a voltage source. Okay, V2 is also called as a one more branch. In this, if we take here, so V1 is called as a one branch. Okay, V1 is called as a one branch and R1 is called as a second branch. And next, if we take the R2 is called as a third branch. And next R3 is called as a fourth branch. And next, if we take the voltage source, V2 is called as a fifth branch. Total here, how many branches are there in the above circuit? There are 5 branches. There are 5 branches and one node. This is called as a node. Okay, so these are all the branches V1, V2 and R1, R2, R3. Total there are 5 branches are there in the given circuit. So this is about the branch. At least one element in between any two elements. Then only we can call it as a branch. Okay, got it? So this is about the branch. Next we'll see about the what is loop here. Loop is nothing but a loop is a closed path inside an electric circuit is called as a loop. Okay, so in the given circuit, this is called as a loop. It is having the closed path. It is starting from one point and ending at that point only without any open path. That's why this is called as a loop 1. Okay, now if you see the one more loop, it is having a two loop. The second loop is also the current is flowing in this direction. It is also having the closed path. The current is starting at this point and ending at that point only, and it is not having any open path. Okay, the any loop, it should have the closed path. If it is an open path, that is not called as a loop. Okay, got it? In the above circuit, the how many loops are there? Number of loops. The number of loops in the above circuits are 2. Okay, now if we take the one more circuit, okay, here now I will erase this. Here number of loops, here the number of loops in the given circuit are 2. Okay, this is the loop 1 and it is the loop 2. Okay, there are two closed paths. That's why here there are two loops. Number of loops in the given circuit are 2. Now if we take the one more circuit, this circuit is having the three loops here: loop 1, loop 2 and loop 3. Okay, I am taking one example circuit. In this circuit there are two closed loops are there. So here the number of, this is a loop 1, it is having the closed loop. Okay, closed, it is a closed circuit, it is also closed circuit, and it is also closed circuit. This, it is having the three loops. The three loops are not having any open path. That's why it is the three loops are having the closed path. That's why it is called as a loop. Okay, the how many number of loops are there? The number of loops in the given circuit are 3. Okay, here there are three loops are there. In this there are two loops are there, because here there is only two closed path. That's why two loops. In this there are three closed loops. That's closed path. That's why number of loops are 3. Okay, this is about the some definitions about the basic electrical circuits, basic definitions. In the next class we will see about the more definitions. Okay.